Okay, welcome back. We're going to get a quick video update today. This is just going to be showcasing the spacer that I built that I machined in the last video. I've installed that on the machine. I'm going to show the change in travels, or the change in useful travels that I was able to get from installing that spacer, as well as just show the machining of a part that I had to make, and that was for a customer. I'm not going to talk about what it's for, but nothing too fancy. It just shows off that I was able to reach the extents of an 8-inch part, and it shows the spacer in action. There's a lot of speculation from people that adding this 3-inch aluminum spacer here would give me a lot of excess chatter just because the head would be sticking out so far. Spoiler alert, it did not. So I'll show you the finishes I was able to get on that aluminum part and just basically show off the differences in the travel of the machine. So one big hurdle that I had to jump through was with this 3-inch spacer in here, the original hardware that mounted, I'm going to go ahead and turn this off, that mounted the head to the Z-axis shuttle right here. So those bolts would sit in this rotary or this circular T-slot right here, and they would extend out and come through the head right here. Now, they used M10 bolts or stock from Precision Matthews. I'm upgrading to M12 as I talked about in my last video, so that's going to give me quite a bit more stiffness just in the overall rigidity of the head being mounted to this shuttle, but it did present some problems. So with that extra 3-inch gap in here, I'll just say it was impossible to find a T-headed M12 bolt that was roughly the 6 inches that it needed to be to extend all the way from the back of this rotary T-slot out through here and give me enough to put an M12 nut on the end of it. So buying some hardware off the shelf. I did need 3 of them, and then I am going to use, as I talked about in the last video, this hole right here is also threaded M12. I actually decided to use a piece of all thread, so it's going to be threaded through in here, stick out, and then this model isn't perfect. This isn't just a hole in the real machine. And I'll have another nut, so I'll have 4 fasteners holding the head to the shuttle. But sorry, I digressed a little bit. So what I decided to do was get some flange-headed bolts. I'll switch over to that right now. So I picked up these flange-headed M12 bolts that I could modify to make the T-head that I was looking for. Even these were rather difficult to find. Even McMaster didn't carry them, which lets you know it's probably not a common off-the-shelf item. So what I had to do to make this work is I took this flange head right here, cut the top of it off a little bit so that it would, just the height would fit in that T-slot, and then machine away the flange itself to give it a T so that it could rotate in that slot. Now, I was a little worried about just taking so much material. This flange is a little bit thin, so I wanted to salvage just every centimeter of material that I could because that's the face that's holding all of the weight of the head. So I'll show you what I came up with here. Turn the stock one off and turn on the modified model. And you can see here I did deck down that head so it fits inside the T-slot, and then you can see I didn't make this actually a T. I followed the curvature of that rotary slot right here, so I just got a dimension of what this diameter was, and I offset it on the inner and outer diameter of this T so that it would be able to rotate in there, but it had as much material as humanly possible left over on it, and it actually gives it a very, very nice sliding fit in there. So that was really all I had to do. I had to modify these. I held them in a 3-jaw chuck, which you'll see in a second, and I took these heads down, and it was perfect. I mounted the Z-axis back, or I took the Z head back off again, and then mounted the plate in there, the spacer, and mounted it all back up again. I'll show you some video of the new travels that I got, and again, just show you an aluminum part that I made that would be the last customer part that's going to come off the machine in its current state. And hopefully, I'm going to stop giving deadlines, but hopefully very, very, very soon the machine will be coming apart. I'm actually, as we speak, as I'm filming or editing this video and making the last part that I need made in the mill before I can take the machine apart and upgrade the mill. So I really appreciate all of your patience, and I know I keep saying, oh, within a week or so this should be all wrapped up, and that was like 4 months ago that I first said that. So I apologize for people that are annoyed with me and my timeline, but I'm doing what I can, and I'm really excited to show you guys the updates. So thanks for sticking by. Here you can see the upgraded, so on the left is the stock T-head bolt that or flange head bolt that we talked about, and on the right is that finished bolt. Here we go, just another angle of it. You'll see just how much shorter the head ended up being, and you can see that radius T-head on the bolt itself. Just one more view there. It really still feels very, very, very sturdy, so I'm pretty happy with it. The upgrade that you can see here on the left is the stock M10 bolt, and then on the right is the M12. That's a shorter length one that I ended up using. And now you'll see I just decided to hold this in the 3-jaw chuck, mount it in the M-locks, and machine it away, and it was really a very, very simple. That's that Kennametal 3/8 inch steel roughing end mill, and it worked great. So I got those modified, and now you'll see the new travels. Do a quick demonstration of before. So you can see just how much extra room I have in the back there of travel. This is an 8-inch plate. And then that is at the Y plus extreme of travel. You can see how much of that plate I'd be missing or unable to machine. Again, going back. So here we have the table in the exact same position that it was in the last video, with the head spacer installed now. Head's not trimmed yet, but so you can see just how much closer we are to that back edge. If I had the hard jaw installed, then you would see I would be even further extended in this direction. A couple other things that are going to help that after all of my upgrades. I am cutting another 1/2 inch out of the saddle down there that'll allow the whole table to move closer to me by 1/2 inch. So I'll be able to reach another 1/2 inch that way. This way I can sneak around the back of parts with cutters. And additionally, I plan to place the vices in a different position, just a little bit closer. I basically like to have about 1.25 inches to the center line in the back here. This way I can make sure lead in and lead out things that are coming into this jaw don't give me an issue. But obviously any further back that I go in this direction sacrifices cutting room, so you want to have it as far back as possible in order to get the maximum out of your work holding. So here is it with it in the extreme minus direction, and then look at that. Extreme positive direction, I can reach both sides of this 8-inch plate now, which is not something I've ever been able to do before, and really will be a tremendous help for the future upgrades. So I think I'm just going to end it here today, and I'll show you guys a little machining footage of this last part that I made. Again, this was for a customer, nothing crazy spectacular, but the raw stock for that was 8.5 inches in the Y, 10.5 in the X, and it was 1.5 inches thick piece of aluminum, and that's maximizing the travels of this machine for sure. I did this whole top part in one operation, so the part was about 1.35 inches thick, so it allowed me to hold on to 2 millimeters or 2.5 millimeters at the bottom, so that little plate that's left over in the bottom there, and I came quite close to the jaws. I'll talk about that in a second, but figured I'd just show off the latest part before I stop and do the upgrade. So thanks for sticking by. All done in one op, thanks to the new spacer. Never would have been able to reach all the sides of this part without it, and without these M-LOK vices. Just in case you want to know how close you can get to a vise, that's 0.08 of an inch. Fingernail almost doesn't even catch on it. Not a bad surface finish. Now just to flip it over, do op 2.